Hello and welcome to the Weekly Squeak, your weekly geeky squeak with me, Chris Chinchilla. It's been some time. I took a little bit of a break. No particular reason. I had been doing a similar format of the podcast for some time. Wanted to stop for a bit and think about what I wanted to do next. So an upshot of that in some ways is I've decided to experiment more with video. I was already experimenting with my DX live stream, my developer experience live stream, and a few other things. And I quite enjoyed it. So I am bringing back the podcast. I'm also adding on a video option that you are probably watching if you're seeing me talk, or you are just listening to the audio version of. At the moment, I'm still experimenting with that. And the best way to record interviews with people in random places. So the video will definitely change over time, but I just wanted to get on with it and get started with it. So today I have an interview with Hasura, who bring GraphQL endpoints to any quote unquote application. And first, as always, haven't changed the format that much, really, apart from releasing in different formats. Let's start with a few links of the week. First, this is an article on Momchil Koichev on DZone. The top 13 GitHub alternatives in 2020, free and paid. No particular valid reason. I was looking at some alternatives to GitHub and GitLab. And this lists several you probably know of. Things like Bitbucket and self-hosting, Gitosis, I think. But then also some others I came across. CodeGiant was one that was quite interesting. And also SourceForge, interestingly, and a couple, Launchpad from Canonical, which is also quite interesting. I think the interesting thing I found with this is that they all are fairly comparable in feature set these days, which is sort of odd when you think there's not much else you could do with Git hosting. You kind of offer the same sorts of things that everyone else offers. I wonder if there's something different that someone could do. But anyway, if you're looking at an option, a different alternative to GitHub or GitLab, then have a look here and see if any of them spark your interest, or if not, maybe start your own. I don't know. Next, this was something called on Wired from as the author, from Gian Volpicelli, called How London's Silicon Roundabout Dream Turned into a Nightmare. Silicon Roundabout is a roundabout in Old Street, East London. Interestingly, I remember when that was a very different place. I actually used to do a lot of gigs around there and do a lot of recording around there. And then over the few years since I left London, I saw it really change quite a lot to this kind of startup mecca. And it's interesting because this story covers a lot of different things. It sort of builds into what has happened now. You know, when you had a physical place that governments and schemes wanted to bring people to, and then people are not going to that place anymore for reasons. What happens to that place? You know, there's a lot of businesses and things that grew up to support places like that. You have places like WeWorks and Google Campus that rely on people going there, and they're not going there. So how does it change? But it also looks at the more longer term, how often startup hubs kind of say, we want to create an environment where someone can be the next Google. Not realizing that, of course, the path to the next Google is littered with companies that fail and people who get nowhere. And often the next Google, if you really want to have that kind of presence in a place, is Google, or as companies like Google. So you often have to kind of invite them in to bring in the other people, which is a certain irony. But that's often the way it is. And I guess a lot of this article is talking about the dreams and ideals of a startup ecosystem in a place, and what the reality might end up being, and how that reality can often end up stinging the people you're trying to encourage in the first place. Rents go up, and the small scrappy, innovative startup can't actually afford to have an office in this place that was meant for them in the first place. These sorts of things. Anyway, it's an interesting article. I think it's probably fairly comparable to many other sorts of locations around the world, and not unique to Old Street Roundabout at all. Probably San Francisco has been like this for some time, and in many other places around the world as well. Next, I've been sort of following this story for some time. And a few people reported on this. This is from Aram Sabeti in particular, talking about GPT-3, an AI from OpenAI that's good at writing things. It sort of strikes fear in many a writer's heart, and actually an idea that I was experimenting with very, very, very loosely some time ago, trying to write fiction with an AI. I would like to try it with OpenAI, with GPT-3, but I think you have to inquire for access, and I'm not sure if experimenting is access status it will give me. But anyway. And so this article details some examples of Harry Potter written by Raymond Chandler, or generating a press release, things like that. Harry Potter by Lil Wayne, sorry. And all sorts of strange examples. And actually they make a sort of a sense. I think these are still, short form, which has been one of the complications of getting, things to write long form. But I have also seen other people try GPT-3 for that too, with a limited degree of success. So it's interesting. I hope and I get the impression that a lot of these sorts of tools will still be used more as assistive tools instead of generating it completely. But I think there's a lot of sort of lowbrow, cheap mainstream fiction that could be mostly generated, and I would hazard a guess that a lot of people would not necessarily notice the difference. Controversial statement maybe. That's what led me to my initial ideas of trying to write something like a romantic comedy, or a rom-com or romantic fiction, through an AI, because sometimes they seem very formulaic. But anyway, I will get there eventually and try it, hopefully. On the subject of automating roles that we thought would not be automated, this was from Mike Lukides on the O'Reilly blog, talking about automated coding, something that came out of Microsoft Build. Yes, I'm catching up with a few old links here. I've been away for a while. And this is a demo from Microsoft of generating code. And actually, this is somewhat similar in that it's good as an assistive technology. And bear in mind, this is Microsoft. So this is probably something they want to put in things like Visual Studio or Visual Studio Code, assistive tooling, which is already there. IDEs already help you a lot by generating, not so smartly, but by generating things for you. And this is somewhat connected to that in many ways, actually. So it's not massively different. And it doesn't really cover the aspect of programmers having to connect things, connecting APIs and that sort of thing, which is actually what most programming really is. So there's still a lot of this kind of work between processes that will still need to be done by programmers. So don't get too worried yet, but still it is interesting as always. Going back in past a little bit. Firstly, this is an article from Ezequiel Bruni on the Web Designer Depot blog, again from a few weeks back. In memory of Flash, 1996 to 2020, Flash has finally been declared dead. And many people a little bit younger than me will not really remember what Flash was, apart from being a pain more recently. But Flash actually opened the doors for a lot of the modern web. It was, of course, closed source and it was proprietary, but it actually it was one of the first things that enabled interaction on web pages, passing values and things like that. So we should not forget its legacy, even if we would certainly like to forget its memory hogging plugin. Going back even further in time, an article from The Guardian by Keith Stewart, the 25 greatest video game consoles ranked. Always love this kind of stuff. This is written by The Guardian, so it has a mostly European focus, which is nice to see. Sega Master System, Sega Mega Drive, and not the Genesis. But it also includes things like the 3DO, which came out of Philips, of course, which is a Dutch company. I'm not 100% sure how well known they were actually in the US. But yeah, and number one, scroll down. Actually, no, I don't want to spoil it for you, but it's probably relatively predictable what it might be. But I was quite pleased to see some of my favorites on there. I'm not a huge console person, but like the Master System and the Mega Drive are definitely in there. But I was more of a Sega person, not a Nintendo person, so I'm disappointed by some of the options on the list, but I do acknowledge their influence. So, yes. And finally, this is again going back a little bit, but another article from The Guardian from Simon Osborne. End of the office, the quiet, grinding loneliness of working from home. I think we've all been now working. Some of us have been working from home in some capacity for a while. We've got used to it. But this is quite an interesting article, and especially focuses on a city like London, where this ideal of working from home is not a reality in many big, expensive cities, and you have no space. And it talks about people working in bed all day long, perched on a kitchen table, these sorts of things, which is not, it would be fine for like an afternoon, but for months and months, it's actually very uncomfortable, very bad for your physical and mental health. And it's quite fascinating how for so much time, so many of us spoke about, I'd really like to work from home. And then it becomes a reality with lack of choice. And we realize it's not all it's cracked up to be, which is not surprising. Many of us who've worked from home for some time have kind of intentionally set up things to be able to let us do that in comfort. Or we know the negatives of it, and we could have told people. But I found this quite a good pragmatic article about the realities of working from home for many. And we forget often not everyone lives in some giant house in the middle of the countryside with 3 spare rooms. A lot of people live in pokey, tiny apartments with next to no space whatsoever. And never meet anybody if they don't go to work and things like that. It's, yeah. And I'm glad someone wrote an article like this. It was shared quite widely, and I think justifiably so, because it really spoke about the reality of the situation for many. And a lot have focused on glossing over this and talking about the kind of living the dream, which, yeah. Anyway. Okay. So, now is my interview with Hasura and their GraphQL for any application. Enjoy.
I'm Tanmai. I'm the co-founder CEO at Hasura. We started Hasura just about 2 years ago, and before that, I used to run a consulting firm along with my co-founder and the founding team that we have at Hasura. And before that, I used to be a freelance consultant in the machine learning and computer vision space. Okay. That's kind of where I did my bachelor's and master's in computer science. I specialized in computer vision, and then I did some consulting for a while, and then I was like, I want to get into something more real. Yeah. It is ironic that after a little bit of time since then, it turns out everything is machine learning and now. So but my interest was kind of towards the more systems side of things. Yeah. And that's kind of how I got started with what we're doing today.
And it's interesting you say that, because we're here to talk about Hasura, which the very large slogan on the webpage, the first webpage is make your data accessible over GraphQL. I would actually like to go back and cover what that means in a minute, but that doesn't instantly spark thoughts of machine learning, but I'm sure there's some going on behind the scenes. But let's maybe go back a step. GraphQL is not new, but it's not that old either. So what is, to be honest with you, this is a fairly technical audience. Most people will probably know what GraphQL is, but or at least heard of it. But in relation to a developer's sort of daily workflow, what is it, and why might they want to use it instead of other options?
Got it. Now that's a really good question. So the easiest way to think about GraphQL is to kind of first understand the layer that it's at. GraphQL is a technology specification. It's not a technology that runs for you. It's not like Kubernetes or Docker or something. It's not a database. It's just a specification. Very similar to how SOAP and REST and OData are specifications of APIs. So GraphQL is just a newer specification for what APIs can be. GraphQL is kind of one of the it's kind of a more it's a nicer API that deals specifically with JSON data. So the idea is that instead of having a REST endpoint where the idea is that you're thinking in terms of resources, and each endpoint kind of represents a resource and an operation on a resource, and then the response of that API has typically, it can be anything, but typically the response is in JSON format, and the JSON structure represents some kind of output, right? If you inserted something, it gives you the output of like, hey, insert successful, and here's some data for you. Or if you're fetching some data, it gives you some data and returns that in JSON. GraphQL kind of uses JSON as a first class thing. It says, well, JSON is the only data format
Mm-hmm.
And if JSON is the data format, and instead of thinking of our API resources as discrete, disconnected resources, we think of our API resources as a graph, or maybe perhaps a more accurate word is a gigantic document. Think of all of your API models together as if it's one huge JSON document, right? And a JSON document essentially is kind of a graph, right? It's kind of a graph of connected things, right? So you have if you have articles, and articles have authors, and authors have addresses, and they have profile information, right? So you can imagine that kind of nesting in your mind, that you have an article list of articles, and each article object has an author key, and the author key now has some data, and then that has some more data, nested data. So you can think of it as one gigantic document, or a list of documents, or a collection of documents, and that collection is basically a graph. And the fact that you're operating, and the idea behind GraphQL is that you're operating on this graph instead of operating on discrete, disconnected resources, right? So you're fetching a slice of data from this graph, right? You're making a mutation. You're running an operation or a command or an action that will go and change something in this graph, right? And that's just kind of a slightly different view of the world, but the reason why it's amazing is that it changes the ergonomics of the way you use the API massively. It's not really a very big shift in anything. It is a big shift in a few things, but it's not really that much of a fundamental technical shift. But the idea that you can now, as an API consumer, think of your resources as a graph, and then you can just query a slice of that graph without having to depend on what endpoint am I querying? I have endpoint 1 and endpoint 2, and they have slightly duplicate data, right? Or I have endpoint 3 where I want more data, but that doesn't exist. So I have to go back to the developer, the API developer, and ask them for more specific endpoint 3. So you don't have to do those kinds of things, and you just get a really nice API. So GraphQL is kind of like an API that's kind of shamelessly designed for JSON. And it's also shamelessly optimized for the ergonomics of API consumption and API integration. And that's the second point. And the third point is that it is an API specification that comes with types, which makes it easier to build automated tooling that do the API integration and consumption. So those are kind of, I would say, the three kind of main facets of GraphQL.
And before we get to Hasura, because there's definitely a space where it fits in quite nicely, and I have personal experience of this, is for the background that you described, or the background that other founders of the company described, what brought you to here? Like, what problem were you trying to solve? Was it just a gap you saw in the market? Like, why create the company and the product in the first place?
That's a really good question. So one of the things that, during our consulting days, what we were doing was the way we kind of ran the company was we were essentially a small platform team and a consulting team, and a fairly large consulting team. And the platform team was basically building tools to help the consulting team in the work they were doing with the customers, right? So our customers would include some of the world's largest banks. They would include two-person startups, right? And as we kind of worked with them, and this was when Docker was just hitting 1.0, Kubernetes was just hitting 1.0, right? These containerization was just starting to happen. The entire framework wave that we take for granted today, React and Angular and Vue, was just starting to kick off, right? And so when we were kind of witnessing and watching all of this happen, we realized that there are two broad things that are happening across companies of all sizes, across teams of all sizes, right? We're seeing that the ability to build applications, the compute aspect is improving day on day. The ability to write code and just run it and forget about it is becoming better day by day. Whether it's a website or a mobile app, or whether it's a serverless function, or it's some compute that's running in a container, all of this kind of application logic that needs to run, that's becoming easy, right? And the story is becoming better every single day. And on the other side, databases are becoming richer as well, right? You have databases are going from single node databases to just being distributed by default, to being scalable by default, right? To being resilient by default, to having a schema by default, right? Where you're saying that you want the flexibility of a NoSQL system, like a JSON collection system, but you also want the database to absorb hard problems around maintaining a schema, around maintaining referential integrity, which is, that's kind of what Mongo's roadmap has been like. That's kind of a newer generation of NewSQL databases. So as these two things are happening, the one gap that is emerging that everybody is still building manually is the API layer and it's the data access layer. And this is a piece that people are just building by hand again and again and again, right? Because it's absorbing a weird kind of technical complexity and some amount of a domain problem as well. So it's absorbing both of these things, which makes it, which has made it historically a little bit hard to automate. But it's also something but it's also very repetitive work, right? What you're doing is you're standing up an API service, you're connecting to all of these different data sources that you have, right? You're mapping those models. You're then setting up relationships between those models. You're setting up security rules for those models. You're making sure that the API service can scale to hundreds of thousands of concurrent users, because databases don't scale like that. Databases scales to a few thousand concurrent users with a connection pool. Right? They don't scale to mobile apps that can handle like 100,000 mobile apps running concurrently. That databases don't handle that kind of load. So you always build this API service in the middle that represents a performance and a security boundary and captures some amount of domain knowledge, which is the mappings of the models, the relationships, the security rules. And you have to embed that into the service and you stand this up. And we were like, this is unnecessary work. This nobody should be doing this. This should be automated. And so we invented a way of doing that. We get into the details in a bit, but so we basically invented a way of doing that. And we had our own version of GraphQL as the API, which we called RQL, and it was a JSON-based API. And that was the API that we used. We developed it internally. And then when GraphQL came out, we were very skeptical of GraphQL. We were like, well, GraphQL is very complex. It's hard to build. It's easy to use, but it's hard to build. Yep. It's not going to become popular, but it did become very popular. The client-side tooling, the adopt, that's kind of goes to say the pull that people had for wanting to get a nicer API to consume data, right? That's what it represented. That even though it's kind of a more complex specification, the ease of use that it brings to the consumer is so high. That's something that we couldn't ignore. And we added support for GraphQL. And that's when we decided to open source the technology as well. So we added support for GraphQL, we open sourced it. That's kind of how it happened.
And you've addressed some of always my concerns and confusions with GraphQL, which is sort of the gap I think you're trying to fill, is a lot of the documentation, the kind of promises of GraphQL is always like, it always feels like it misses something. It says, there's this spec and it does this and it's amazing and it's great. And you look at these examples and you sort of understand them, and then you try to figure out what you actually need to do to make it work for you. Yeah. And that actually always seems to be something that's very missing in everything I ever read. And understanding what I'm actually supposed to do, and actually understanding that it requires a fair bit of change to your application and things like that. I always find that's a slight lie with GraphQL. They seem to completely fudge a little bit, and it's something that always annoys me about it. It's actually quite difficult.
You're 100% right. It's one of the reasons why I was very skeptical about GraphQL. Is that it's one of those, historically we've always seen technology become simpler, right? We like writing a REST endpoint today and serving it up, right, to the entire world that can scale to millions of people is 10 minutes of work. It's unimaginable how far we've gotten in just 10 years, right? It's crazy. It's become so simple. And on the other hand, you have a technology like GraphQL that's vastly more complex than what came before it, right? It doesn't make things simpler. It makes things simpler if you are a Facebook, which is why they invented it. But it doesn't make things simpler for everybody else in the world, who by definition is not Facebook, right? So it's very counterintuitive, and it was something that I was very skeptical of. And I liken it. I liken GraphQL to be very similar to maybe in the 80s and 90s when we were looking at SQL systems, right? Yeah. It's like SQL is a great API to use to consume data from a database. It's amazing, right? But nobody's building a SQL server. The only people building a SQL server are database folks. Yeah. Because for them, it's worth absorbing the amount of complexity that they try to abstract away and provide a neat interface on. It makes sense for them. But nobody in their right mind goes and sets up a SQL server. right? There is, I mean, if it's just from a technical standpoint, all the APIs that we use today, REST APIs, JSON APIs, there's no reason for us to have a separate protocol. We could have done all of that work over SQL as well. SQL is just a specification, right? Yeah. SQL is just a specification. I could have built a SQL web server and my mobile app could have communicated with the web server in SQL. But you just don't do it because it's very complicated. You have to implement a language parser. You have to understand the SQL language. You have to parse it. You have to validate it. You have to check against your own internal metadata whether this SQL query is right or not. You have to implement essentially the bits of a compiler, a query planner, a query execution engine. By the time you're doing that, you're like, nah, unsubscribe. I'm not going to build. I am not building this. I am going to use a SQL service like a database, and I will be done with that, right? So I think it's very similar to that, right? And you're spot on with the fact that it's one of the things that GraphQL is not very new. GraphQL is 5 years old. By the time Kubernetes was 5 years old, it was on fire, right? I mean, Kubernetes today is just slightly more than 5 years old, right? But it's on fire, like it's everywhere, right? It has a degree of penetration that GraphQL does not have. And look, I'm comparing apples and oranges, but just in terms of like thinking about technology trends and penetration, right? The reason why GraphQL adoption has not been that fast is because it is complicated. Like you said, it's not easy, right?
Yeah. So this is where Hasura comes in. I'm going to start with the open source version first. So yeah, the tagline on the main web page, instantly make your data accessible over GraphQL. Is that also in the open source version, or is the open source version something else? Okay.
No, that's the open source version.
Okay. So if I had, I'm making some assumptions here. If I was to have, an old SQL-based CMS, I've got posts, users, etc., and I want to convert it to GraphQL, I can use Hasura for something like that.
Exactly. Just stick a Hasura in front of it.
And what do I do then? So what do I do?
So you go into so let's say you have like a database lying around, right? And you're like, oh man, this database, it has billions of records, it has thousands of tables, but it's this old ass system. I don't want to use it. I don't want to connect directly to it because it's hard to connect directly to it. I have to get somebody to program against it, but I need to build new applications. What do I do? So you put a Hasura in front of the database. What Hasura does is, so there is a build step, or like a step when the user is kind of configuring Hasura, and then Hasura runs, right? So as soon as you point Hasura to the database, Hasura introspects that database. It loads up all the catalog models, all the tables, all the views, all the stored procs, everything that you have. It loads all the types that they have. It loads that up, gives that to you on a UI. And then what you can do is you can say, well, I care about these models. And these are the relationships between these models, right? And so sometimes you have foreign keys in your database. Sometimes you don't have foreign keys. That's fine. It doesn't matter. You can use those foreign keys, or you can just use join conditions, and you can say, hey, this column on this table and this column on this table, they're used to that helps me create a relationship. So you kind of do these kind of annotations, or basically what we call metadata. And you set up this metadata via UI. And then once you get used to the UI, if you prefer, you can just write the configuration file yourself. It's just JSON and YAML. So you can just write the configuration file which represents that metadata. And then once you write that out, that's it. Hasura now becomes a GraphQL service. Or Hasura becomes the GraphQL API that will use this metadata to interact with the database. The two kind of key problems that we're solving here is one, that GraphQL translation, that the ergonomics of using a GraphQL API and the experience of having one large JSON document, or list of documents that you're operating on, which is nice. And two, the security problem, which is that, the reason why you've historically not been able to expose your database directly to applications is because these applications today they're not internal applications, right? It might be an application it's an Android app, or it's a web app that's running on the device of a user that's not in your org. Right? The context has changed from us being inside the bank. Hey, Chris, you're the database owner, and Tanmai is the Java app developer, and we have a little Java app that talks to the database, and it's all in the same building, and all of the users are all employees of the bank. Right? That's no longer the case. Now you have a case where the database is inside the bank building, sure, maybe, but the app is in the hands of a user on an untrusted device that can be compromised by a hacker, it's crazy, right? It's completely different. It's the application development context has changed. And so what Hasura lets you do is when you're specifying that metadata, you specify security rules as well. And these security rules are very fine-grained and powerful. And what that lets you do is say that even if it's an end user, that you're using the GraphQL API for an end user application, you're able to fetch and operate on data that is scoped in to you. So if you're an end user and you're fetching your profile information, in your API call, there is nothing that you can do on your app that will ever fetch somebody else's data, right? Or if you're operating on your profile, it's only your profile that you can operate on. But it's not just profile; it could be a document. And the reason why you have access to a particular Google Doc is, you can have a very complex set of conditions. The Google Doc is public, or the Google Doc has an editors list, and you are one of the editors, or the Google Doc has a viewers list, and you are one of the viewers. Or you are a friend of the owner of the Google Doc, and that's why you have access to this, whatever that complex kind of set of conditions is. Hasura absorbs that in that metadata rule engine as well. And that's kind of what makes the GraphQL API very useful, right? Yeah. That it's nice to use, but also it's possible to use.
And as far as I can see, you're just supporting Postgres right now.
Yeah.
Is there a reason for that, or just on the roadmap?
It's just on the roadmap. So we started off with Postgres because Postgres is kind of hot, right? It's kind of it's like Uncle PG is cool again, right? It's like it's this ancient database that's suddenly become amazing.
By Oracle is probably the
and it's not. Yeah, there you go. And Uncle PG is a bit of a hippie, so that's cool as well, right? So I think those and of course Postgres is a rock solid amazing database, right? So it's become popular, and that really helped because that was the first that using that as the first database to build the product in the community and mature the product offering was a great start. We're doing a few more databases. We're going to make an announcement sometime in about a month and a half, about 4 to 6 weeks, and then we'll do another set of databases towards the end of the year.
Yep.
So
just to clarify for those maybe who are not so used to understanding how GraphQL works, GraphQL itself, this is where it sometimes gets a bit confused. You should think of GraphQL just the same as a REST API. The Postgres data is still the data.
Exactly.
It's just a sort of an instant spec on top, and I guess so does Hasura. It creates the things like the spec for you mostly automatically and stuff like that.
Exactly. So you don't have to deal with the GraphQL bits of it, right? So you don't have to deal with the bits of like, here's this is what the GraphQL specification is. This is how I make the GraphQL query work well. This is how I validate it. These are performance problems. How do I integrate a health check mechanism into it? Because GraphQL APIs have a very different way of reporting errors, right? The entire ecosystem of tools that we've had over the last decade and a half of 400 errors, 500 errors, that doesn't work with GraphQL anymore because GraphQL can return partial errors. GraphQL has this concept of you can make a query. That same query might fetch data from multiple sources. So, for example, with Hasura, you might be fetching data from Postgres and from Stripe. So you can join data across these data sources, right? So you can fetch data from Postgres and from Salesforce, or from Postgres and a legacy REST API. So Hasura can consume Postgres, REST, and GraphQL as data sources. And so now when you make and so now when you make a query that fetches data across these data sources, one of those data sources might fail. And the way GraphQL reports this is that you get a partial result and you get a list of errors as well that tell you that certain things have errored out. Now, but all of this is returned over a HTTP endpoint that always returns 200. That's just the default kind of convention. All GraphQL clients and all GraphQL servers forever just exchange 200s. Yeah. So from the point of view of an API gateway or a health check mechanism or an alerting system that you have, that's never going to tell you what's going wrong. Because you're just like, everything's dandy, but it's not, right? Because you have this partial error thing. So those are the kinds of things that you have to figure out, and then you have to worry about getting in production. And especially in enterprise environments, this is not. You don't want to solve this part of the problem, right? You're like, no, we fixed this. We've fixed reliability. We've gotten all of this working. There is no way that we're going back and changing all of that tooling just to get GraphQL to work. So Hasura kind of addresses that. It makes sure that compatibility with APM tools and alerting tools is all kind of maintained, but you still get the benefits of GraphQL.
So just to clarify, well, not clarify, but just to build on top of something you said there, and it sort of somewhat leans into what you have with the cloud offering.
Yeah.
So the cloud offering would imply that you are going to handle a lot of the running the GraphQL server, I guess.
Yes.
So if
exactly.
I'm doing the open source version, I still have to, I mean, what do I have to have running if I want to run this myself then?
Yeah. So the open source version is basically we ship it as a Docker image, right? So we release. You can take a daily build off, or you can take tag versions, and you take this Docker image and you run it wherever you want, right? You run it on your cloud vendor, you run it on your laptop, and then you connect it to your database. The cloud version is essentially saying that, well, you don't need to have this Docker container running anymore. You don't need to scale it up, scale it down, and stuff like that. What you can do is keep your data sources wherever they are, your own databases, wherever they are, and just connect Hasura Cloud to them. Mm-hmm. So it's kind of like, the analogy that I draw is like, it's kind of like a CDN, but instead of a CDN that's distributing static data pointing to static sources, this is kind of like a dynamic data CDN. It's kind of like it's fronting dynamic data. It's fronting operational data instead of it fronting static data. So it's kind of, that's kind of the mental model, right? So your API service is just this infrastructural component that exists on top of your data sources.
Okay. So let's just break down some of the products you do have. So you have a reasonably standard suite of kind of the offerings for an open source kind of company. You have enterprise. So on premise, what do you add in there versus someone running on premise themselves, I guess?
Yeah. So the three flavors are basically, the open source engine that you can go take it on wherever you want. Enterprise, like you said, which is the enterprise offering is intended to be an on-premise offering. Mm-hmm. So basically, it's kind of like it's a version of Hasura that solves certain problems that you have running in an enterprise grade environment, and things around everything from security, performance, scalability, compliance, a bunch of those things. Takes care of that, and then you still run it on-prem. Or you move to the cloud version, which is kind of like the enterprise version, but completely serverless, pay as you go or pay as you consume, like consumption and SaaS model. And so that's kind of the suite of three offerings. The thing that's kind of interesting about the way that we think about the cloud version versus the enterprise version is that when we give folks our enterprise version, they kind of have to host it and run it themselves, right? They have to deal with the operational aspects themselves. But the cloud version is kind of re-engineered from the core, so that Hasura itself is multi-tenant true SaaS. So unlike other open source offerings where you often go to a cloud version, it's essentially managed hosting. Mm-hmm. So it's like saying, I have 3 instances of Hasura, so give me 3 instances of Hasura on your cloud. And this is the memory configuration and CPU configuration. So it's basically becomes like a cost plus model, right? It's a markup on top of what you would have had if you had AWS yourself. But what we've done is we've re-engineered that so that you as a consumer, you never see how many Docker containers of Hasura you have running, what the CPU and RAM is and whatnot, right? For you, it's just like it's the amount of data that flows through Hasura, and that's it. Whether you have 100,000 concurrent users, 1 million concurrent users, 10 users, you're making 100 API calls per second, you're making 10,000 API calls per second, doesn't matter. You don't have to worry about it. We'll take care of, we'll make it a SaaS, or we'll make your data a SaaS, if that makes sense. So that's kind of the way we like to think about our cloud version.
Okay. So just to kind of wrap up some of the how you fit into this landscape of what you're doing next. I can think of maybe a couple of other similar-ish competitors to what you're doing. I'm guessing if I'm correct, you're aware of them. So I don't necessarily have to.
If I'm doing a good job.
I can only think of one, but I'm sure there is more than one.
Right.
So what do you offer in comparison to some other companies that are doing similar things, shall we say?
Yeah. No, that's a very good question. Question that often comes up as well. I think the core difference is we think of your GraphQL API as a service that you should get, almost as a part of your infrastructure. Not so this kind of instant, they instantly make your data accessible over GraphQL. That's kind of the Hasura approach. Yeah. The approach that some other players maybe in the ecosystem have taken, in the GraphQL ecosystem specifically, is kind of an approach of saying, we'll help you build your GraphQL service. So it's a set of libraries that you use to build a GraphQL server. Whereas Hasura is kind of saying that, hey, we're a declaratively configured GraphQL service, right? So it's like we are the GraphQL service, and you have a declarative kind of programming model. You have declarative configuration. And if you give Hasura declarative configuration, it can take care of everything from application level caching to security to performance to whatever, versus kind of a library driven model where you have to integrate a bunch of libraries together to stand up a GraphQL service. And obviously there are pros and cons on either side. But ultimately the problem that we're solving is data access. Okay. And the problem that we're solving is saying we want to make data access easy. Today, a GraphQL API is your favorite API, but tomorrow it might be something else, right? In a year or two, it might be something else. And that's how the world is, right? The world gets better and we'll change with the world. But this problem, the hard technical problems of data access, we will keep solving them. In fact, with some of our healthcare customers, they've people who want, like, for example, FHIR is a healthcare, is a spec. Right?
Yeah. I've actually interviewed some French students who were working on something around that a couple of years ago.
Exactly. Yeah. And so for us now, it's trivial to automate an FHIR spec compatibility, right? Without any work, because at the core of it, we have the metadata to give you the API that you want. And so for us, it's just a matter of saying, flag it. Here's your FHIR API, right? Here's your REST API. Here's your GraphQL API. So we are really solving that data access problem over GraphQL, right? As opposed to helping you build GraphQL. So that's kind of the philosophical difference. But otherwise, in terms of, and which is why we kind of have major benefits on performance and caching and the non-functional requirements that Hasura can service are order of magnitude better usually. But that's the difference that comes in from this philosophical approach.
And how old is the company now?
Just slightly more than 2 years now.
Okay. Yeah. So what's next? What's next on the roadmap in the next 6 months?
Yep. Databases, more databases.
Okay.
That's the biggest item on our roadmap. There's a bunch of other things as well on cloud, especially with application level caching and stuff like that, which a bunch of cool things there. But I think the biggest item that we're extremely excited by is support for more databases, especially native support for distributed databases. Both in the Postgres, MySQL, and NoSQL family. But there's some amazing work that we've been doing with collaborating with vendors in the ecosystem. Where that's just a phenomenal story, right? To have a globally distributed GraphQL API on a globally distributed database. Now there's no excuse not to build it on Facebook, basically. So
there might be, but yeah.
So that's kind of the most exciting.
Okay. And what might be some very new or very new or very soon to be, I'm not quite sure how to word that properly, features that are coming that you really want to make sure that people know about?
I would say that I think two of the coolest things to watch out for that we already have preliminary support for, which is getting better day by day. And then I think our two good things to watch out for there are open tracing support and application level caching. So open tracing support kind of gives you full distributed tracing out of the box. The plumbing for full distributed tracing for all of the data sources that you're integrating with, all the way from your client all the way to the different data sources, and application level caching kind of automates the hot queries that you need to cache for your application users that you need to do manually, things that you have to do outside the database, and we automate that. So I think those are two extremely exciting things, both from the economic benefit of not loading up your upstream servers, and also the ergonomic benefit of it just works out of the box. Okay. So those two things we're excited about.
And I don't know why I want to ask this question. It's not a question I normally ask, but where does the name come from? Is there anything particular, or is it just? No, it's a little bit of just a thing, but it's also Hasura is a common South Asian word that refers to demons. Okay. You have the little we have
the little thing. But the interesting thing is that in a lot of South Asian mythology, demons are not evil. Demons are protectors that ward off evil. So if you travel in South Asia, you'll often see like these demon faces that are outside the walls of houses or on doors, and the idea is there to. It's quote unquote warding off evil, right? So it's supposed to be this tradition thing. So and for us it's a pun on DAEMON, demons, which is like background processes and servers. And so that's where Hasura comes from, and H is Haskell because all of our backend is in
and that's the Haskell logo inside.
That's the Lambda, which has thankfully aged really well over the last few years because of the rise of serverless, and Hasura works really well with serverless as well, and serverless is often also the Lambda and the thing. So
I once interviewed someone from Microsoft who said I just looked in the approved names dictionary and picked something. So
startup. The joys of being able to name things at a startup, I guess.
That was my interview with Hasura. Hope you enjoyed that. I do have some things to share with you. I've started a new job as tech writer at Chronosphere just the past week. So watch much more from me on that. The podcasts I was talking about many, many months ago are still not released, but they are all actually finally edited. So watch this space. Very, very soon they will actually be released. Likewise, my live streams, I experimented for a bit. I didn't really promote them. I learned a lot of lessons, and I'm now starting them properly this week. I'm doing a lot of things again this week. August probably is the worst time to launch something, but hey. So that's some new things there. What else? It's hard to think. What have I done in the past few months? Quite a lot. Have a look at christianchiller.com, see what I've been up to, see what's coming. There's definitely still things missing there. I've sort of been taking a bit of a break maybe from lots of things, or taking a break to work on things. But it's not necessarily looking like there's been much progress on them. But there has been. I'm just, been trying to finish them off, I suppose, and doing a lot of open source work and things like that. I will be at KubeCon next week, 17th to 20th, interviewing a few people, say hi. Obviously not really much else, but you can also sign up for my office hours. There is a link on christianchiller.com as well. There also a pinned tweet. You can sign up for my office hours if you want to talk about documentation, tech blogging, tech journalism, whatever you want to talk about. And I'm about to print a new batch of stickers because I got a new laptop and I need a new chinchilla sticker for my laptop. So sign up for my mailing list, which will also be restarting this week. And put your address in the sign up form and I will make sure you get a sticker when I get some new ones. You can find more details about me at christianchiller.com/contact/support as well if you want to find ways to donate to the show. And maybe I need a new catchphrase. I'm not sure if I need a new catchphrase, but I can't think of anything right now. So I'll just stick with the old one for now. This has been the Weekly Squeak after a little bit of a break. I hope you enjoyed it. Hope you're glad to have me back. I'm hoping to fit things in. I have a nice backlog of interviews to get through to bring you at least a next month of episodes. And until the next time, if you have been, thank you for listening. And I suppose I should now add, thank you for watching.